Okay, we want to talk about the ranges of the complete basic functions. Okay, for the basic quadratic, the range is, well, if we look at it, we can see that we have y values starting at 0, going up to 4 for the extended basic, but then there's no limit to how far they go, so that the range would consist of all numbers from 0 through infinity. Include 0, and infinity isn't a number we can't include it, it's something we just approach, which is why we use an open parenthesis. Okay, that's your basic quadratic. Basic exponential function. The range is, again, 0, infinity. We've seen that if we take bigger and bigger negative numbers, we go further and further in the negative direction, we get reciprocals of higher and higher powers of 2, which approach but don't reach 0, and I just said it, and I wrote it wrong. And we don't get the value 0 because there's no value of x for which the reciprocal of 2 to the x would be 0. 2 to the x is always some number. The reciprocal gets really tiny, but it doesn't ever actually reach 0. I've said that in a number of ways. Okay? Now, for the basic reciprocal function, let's take a look at that graph. For the basic reciprocal function, and not for the complete reciprocal function, I'm sorry, we see that we've already discussed when you take the complete function, you never reach 0 because there's no number whose reciprocal is 0. Very similar to the reason the exponential function never reaches 0. But we can go any number above 0 on up to infinity here, and any number below 0 to negative infinity on this side, so that the complete basic reciprocal function, it's negative infinity to 0 union 0 to infinity. And I should have used the word complete here. I did say these are complete basic. Just to emphasize the difference between the basic and the complete basic. And then for the basic reciprocal square, very similar. We can't reach 0. Y can't reach 0, no matter how big x gets, but it can be any number above 0 and goes on to infinity. So, and it can't be negative because reciprocal square can't ever be negative. Just 0 to infinity. And then it should be pretty clear that the cubing function can take any value. The y values go all the way down to negative infinity and all the way up to infinity. So the complete basic cubing function. Anything from negative infinity to infinity. So there are the domains, there are the ranges, there's all the information about the domains. Go back to the original picture.